Hi, I'm Unsu Kim, a master's student at KAIST, and I will present our CVPR paper called Word in a Frame, Understanding Culture Mixing as a New Challenge for Vision Language Models. Before introducing our work, I will briefly explain the concept of culture mixing. The term may be unfamiliar to you, but culture mixing is actually very common in everyday life. Culture mixing means that culture cues from different origins appear together in one scene. So our key motivation here, which is also illustrated in the cartoon on the left, is that real-world images often contain multiple culture signals, and models need to preserve the identity of each element as well. A simple example of culture mixing is a club or potluck. Many foods from different countries appear on the same table. For people, this scene is ordinary, but for vision language models, each food items can be a potential culture cue that can distract from the target food. Another example is eating Korean cup noodles in front of the Eiffel Tower. The food points to Korean culture while the background points to the France. Culture mixing also appears beyond food, such as international marriages with traditional clothing from different cultures. The broader point is that mixed culture scenes are common, so robust culture recognitions should work under this mixed context. In this paper, we ask, can vision language models perform robustly in culture mixed context? Our paper covers two parts. First, I will introduce the culture mixed task and benchmark, and then I will show how current vision language models behave, focusing on their performance drops. So this slide shows the overview of our culture mixed benchmark and task. The benchmark contains more than 200 food images, 50 background images, which is collected from the existing data set, and they are across over 30 countries. We have 4 mixing conditions, and the 4 tasks isolate different sources of distraction. For example, single food is the baseline with no distractor, and multi-food combines another food item on the single food images, and single food with background adds a culture background on the single food images, and multi-food with background combines both food and background distractors. We also consider whether the culture elements in each image come from the same or similar cultures or from different cultures. This is due to analyze the effect of culture distance between elements. I will show the corresponding result in the following slides. For evaluation, we ask the model to name the target food and identify the country. This means that we measure both food name accuracy and country origin accuracy. This is the result of overall model performance, and the performance drops when we move from single food images to culturally mixed conditions. Also, background distractors are especially harmful compared with food distractors. We further analyze the effect of culture distractors, and our finding shows that culture distractors shift predictions toward their culture, which means that when a distractor is added, models often change the answer from the original single food prediction to the distractor's country or a closer culture. Also, background cues exert a stronger influence than food distractors. We also analyze the effect of culture distance between elements, and we found out that when the target and distractor come from the same country, recognition improves and predictions are more stable. These are our conclusion, and if you have any questions, then please feel free to contact the first authors. Thank you.